The famous physicist, Albert Einstein helped develop the idea of space-time as part of his theory of relativity. Prior to his pioneering work, scientists had two separate theories. To explain physical phenomena, Newton's laws of physics described the motion of massive objects, while James Clerk Maxwell's electromagnetic models explained the properties of light. But experiments conducted at the end of the 19th century suggested that there was something special about light. Measurements showed that light always traveled at the same speed, no matter what. Einstein pulled all of these ideas together in his 1905 theory of special relativity, which postulated that the speed of light was a constant. For this to be true, space and time had to be combined into a single framework that conspired to keep light's speed the same for all observers. A person in a superfast rocket will measure time to be moving slower and the lengths of objects to be shorter, compared with a person traveling at a much slower speed. That's because space and time are relative. They depend on an observer's speed, but the speed of light is more fundamental than either. The space-time he described is still known as Minkowski space-time, and serves as the backdrop of calculations in both relativity and quantum field theory. The latter describes the dynamics of subatomic particles as fields. How space-time works. Nowadays, when people talk about space-time, they often describe it as resembling a sheet of rubber. This, too, comes from Einstein, who realized as he developed his theory of general relativity that the force of gravity was due to curves in the fabric of space-time. Massive objects, like the Earth, Sun or you, create distortions in space-time that cause it to bend. These curves, in turn, constrict the ways in which everything in the universe moves. Because objects have to follow paths along this warped curvature, motion due to gravity is actually motion along the twists and turns of space-time. A rubber sheet is two-dimensional, while space-time is four-dimensional. It's not just warps in space that the sheet represents, but also warps in time. The complex equations used to account for all of this are tricky for even physicists to work with. Einstein made a beautiful machine, but he didn't exactly leave us a user's manual. Just to drive home the point, general relativity is so complex that when someone discovers a solution to the equations, they get the solution named after them and become semi-legendary in their own right.